Hello guys, in this project is about wine quality prediction using machine learning. So here we will predict the quality of wine using some chemical parameter. Let's understand more about the problem statement. Consider there is a wine manufacturing company and this company wants to create a new brand of wine. They want to find the quality of the wine using several parameters like acidity, citric acid content, etc. We are going to build a machine learning system that can take all the chemical parameter and determine the quality of wine. So now let's understand the workflow. We need this wine dataset which has chemical parameters, values and label values. Here the label is nothing but the quality of the wine. We will train our machine learning model using this label dataset. So when you train a machine learning model with label dataset, so that type of learning is called supervised learning. When we use unlabeled dataset, it is called unsupervised learning. Once we have this wine dataset, we will do some data analysis on this dataset. We have several values in the dataset. We need to find which parameters are important for having the quality of the wine is good. So there can be several relationships between various features of the value. We will also use some visualizing technique like plots and graphs. The data analysis part gives you a better understanding of dataset. So once we have analyzed our wine dataset, we will preprocess the data. So this step is called as data preprocessing. So we cannot feed this raw data to our machine learning model. We will need to do some processing so that it becomes compatible with our machine learning model. Then we will perform train test split. We will train our model using this training data and test our model with the testing data. This test data is used to evaluate our model, that is how well our model is performing. So this is the reason for splitting the data into training and test data. In this case, we will use random forest model, which is a supervised machine learning algorithm. Once we train, we will evaluate it based on our test data. So it gives us the accuracy score or performance metrics of our machine learning model. So let's get into the coding part. So first we will load our data set here. So you can see that I have already loaded the wine quality dataset, and dataset link I will provide in the description box. You just have to right click here and upload the dataset here. So let's start with importing the dependency. Dependencies are nothing but the library and function that we are going to use in our code. So let's start. Cborn as SNS from sklearn dot model selection. Model selection, we will import our train test split. Test split again from sklearn. So we'll ensemble en ensemble, import random forest classifier. Random forest classifier, and finally from sklearn matrix import accuracy score. So these are the dependency we will import. So first is import numpy as np, that is used to create numpy arrays, and pandas as pd, that is pandas data frame, useful for processing the data. And matplotlib and cbon is used for data visualization. It will help us to plot graphs. And we will use the model selection, that is a train test split. And we will use random forest classifier. So random forest is an ensemble model which uses more than 2 or 3 models. So that is meant by ensemble. So we will import from sklearn ensemble, then we will import a random forest classifier. So you can say that random forest is a decision tree ensemble model. So we will import the accuracy score for evaluation of machine learning model. So now we will load a dataset into a pandas data frame. Equal to pd.read csv. So we'll click here and copy the path. Just click on 3 dots and copy the path, and we will paste it here. So we have loaded our dataset into pandas data frame. So now we will check for the number of rows and columns in the dataset. So wine dot shape. So you can see that there are 1599 examples of data, and there are 12 column. Last column is the quality of wine, and there are 11 feature column and 1 label column. The 12 column is our label column. So let's see our column. So let's see first 5 rows of the data set. So you can see the first 5 rows of the data set. There are 12 columns. So here they are. So now we will check for the missing values. So let's do that. Is null dot sum. So you can see that there are no missing columns in our data set. So which is good, kind of good, that we don't have to drop or do any imputation for that. So now we will do statistical measures on our data set. So wine dataset dot describe. So you can see the count, the mean, the standard deviation, the minimum, 25 percentile, 50 percentile, 75 percentile, and the maximum value. So for each column, it is the statistical value is shown. So now we will proceed for data visualization part. So we'll first visualize the quality of the data. So let's plot by using graph. So SNS dot cat plot quality, and our data set is our bind data set. And kind will be our count. So these are the different quantities values. So we don't have the value, we don't have the quantity values as 2 or 1. So the quantity values start from 3 to 8. The higher the value, the better the wine quality. So number of values is greater than for 5 and 6. We have 11 parameters, 11 parameter value. We will compare these values with quality and see which is correlated with this quality column. So before that, we will also do some other data visualization with other columns also. We will visualize volatile acidity versus the quantity. So let's proceed with that. Plot plt dot figure fixed size equal to 5,5. Let's say SNS dot bar plot x equal to quality comma y equal to volatile acidity data equal to wine data set. So like if the volatile acidity is high, the quality of the wine is less, and vice versa. So volatile acidity and quality are inversely proportional. You can say you can infer from this graph that volatile acidity and quality are inversely proportional. So let's plot another thing with let's plot the citric acid with the quality. So we will follow the same procedure, just so we will copy this and quality and the citric acid contain citric acid with the wine dataset, and rest all will be same. So we can see that if the citric acid content is more, then we are getting high quality of wine. So citric acid is directly proportional to the quality. This is the advantage of doing the data analysis part, as it helps us to understand our data better. It helps us to understand which columns are more related to our level. We can check for other column relation as well. From that, you can infer which columns are directly proportional to quality and which are inversely proportional to quality. So for now, we will proceed further. So before that, I want to say about correlation. So like there are two kind of correlation. One is a positive correlation and one is a negative correlation. So what is positive correlation? Like if one value increases, the other value also increase. So in that case, there is a positive correlation. So if one values increases and the other values decreases, then in that case, there is a negative correlation. So we will see correlation within this data set. So correlation equal to find data set dot core. So it will find a correlation between the data. So let's run it. And before that, let's construct a heat map. So heat map is generally used to made is to understand the correlation between the columns. So let's plot that. PLT dot figure fig size equal to 10, 10 SNS dot heat map correlation comma C bar equal to true comma FMT equal to, let's say 0.1 F again, and note equal to true, and note KWS equal to, give the size size as 8, let's say, and C map equal to let's say blue. So we'll run this. So this let's this FMT is 0.1 F. That means that one floating point value. You can see that there is only one decimal point, one floating point value in the entire heat map. So this C map equal to blue. The graph will be shown in as a blue, in blue format, and like these are the annotation, the anode 1, anode equal to 2, the annotation, and this is the C bar. This is the C bar, and darker the color, it means the two values are highly correlated. So correlated with each other. So lighter the color, it is negatively correlated. So you can see that diagonal one is dark. Basically, both two columns are same. Ignore. So we will ignore this diagonal. So like, see, you can see here the fixed acidity is compared with the fixed acidity. So and it's having the highest correlation. So it's darker in shade. So we will generally ignore this diagonal one. So now we will proceed, and we will separate the data in level. Wine data set dot drop, will drop the quality column, And so we will print and see our X value. So here is our X value. So for Y, so we will perform a label binarization. So let's first write the code, then I will explain. Dot apply, we'll use a lambda function here. So let's print our Y value. So this is our Y value. So here the lambda function, lambda is generally it's an anonymous function. Lambda is used for this kind of operation where we need to replace the value. So here we are using lambda function. So like before, you can see that the quality versus the number of count, we have value like quality versus number of count. Like we have value of 3 4 5 6 7 8 quality. I want to binarize this value. So what is binarize? Binarize means, binarize means I want this quality to be two values. Like I want labels to be good and bad. If the quality is 7 or greater, then greater than 7, then I want that quality to be good. And if the quality value is 6 or less than 6, then the quality is bad. This is called binarization, because we are binarizing the labels into two particular values. We will replace all the values of 6 and less than 6 to 0, and all the values of 7 and 8 to 1. So here we are just doing the same thing with this lambda function. So lambda function, as I told you, is used for this kind of operation where we need to replace the value. So for greater than 7, we are placing it 1, and for otherwise 0. So let's proceed. So now we will train and split, train and test. We will perform train and test split. X train, X test, Y train, Y test, train, test split, give our X and Y value, test size, will give, let's say, 0.2, give random state equal to 2. So basically, the text size is 0.2, like only 20% of the data set is used for testing purposes, and the remaining 80% is used for the training purposes. And here the random state equal to 2, its random state is just to reproduce the same code, like your and my data set will be equally stated in same way. So let's print our Y shape, and we are more concerned about a Y train and test. So Y train dot shape, Y test dot shape. So for Y shape, there are 1599 examples of datasets, and for Y train, there are 1279, and for Y test, there are 320. So now let's start our model training. So we are using a random forest classifier. So random forest is an ensemble model. So ensemble models are those that uses 2 or 3 models in combination for prediction. So let's start with that. Model equal to random forest classifier. So we will fit our training data into this model. Model.fit X train, Y train. So we have fitted our model. Now let's see, and let's check our accuracy score. So we will directly we will directly check, in this case, we will directly check the accuracy of the test data. So let's go for that. X test prediction equal to model.predict test data accuracy equal to accuracy underscore score underscore test Y test. So let's first do our let's execute this code and print our test accuracy. So print test data accuracy. So you can see there is almost 91% we are getting our test data accuracy. So now we will randomly make a predictive system. So for that, input data equal to. So for that, we will do one thing. We will take this data, open with in Notepad, and so loan status prediction. Sorry. open with a notepad and randomly take value. Let's say this value. So we will keep it in close bracket. So we will cut that last column as it is the valuable column. So changing the input data into a numpy array. So input data as numpy array equal to np dot as array. We'll pass the input data. So now we will receive the data as we are predicting the label for only one instance. Input data reshaped equal to input data as numpy array dot reshape. Keep it as it is used for reshaping only for one instance. So 1 minus 1. So now we will use the prediction model equal to model dot predict input data underscore reshape data. So we'll print our prediction. So if our prediction is like if it is 1, so print good quality wine. Good quality wine. Else will print bad quality wine. So we will run this. So you can see it's a bad quality wine. So we remember that we have deleted the 5th column because it's our outcome should be 5. So you can say we have created a model that for greater than 7 only the quality will be good, otherwise it will be a bad quality wine. So our model is working fine with good accuracy. So that's all for this video. Hope you enjoyed this video. Thank you.